Welcome to lesson 6.2. Today we're going to talk inverse functions and relations. We have two vocab terms for today. We have inverse relation, and that is the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. And we have inverse function, exchanging x and y in the given function and solving for y again, written as f to the negative 1 of x. First thing we're going to talk about is inverse of a relation. Inverse of ordered pairs. So if we have the relation given here with the points 0, 2, 3, 4, negative 3, negative 2, and 2, 4 again, all we need to do is flip the x and the y values. So 0, 2 becomes 2, 0. 3, 4 becomes 4, 3. Negative 3, negative 2 becomes negative 2, negative 3. And so 2, 4 would become 4, 2. So in a relation, you flip the ordered pairs. So if I were to be given the relation negative 9, 10, 1, negative 3, and 8, negative 5, and I asked to find the inverse, I would say the first point is 10, negative 9. The second point would be negative 3, 1. And the third point would be negative 5, 8. Okay, so again, all you do is switch your x and y coordinates of each ordered pair. So our next example here, we've got the relation that has the points negative 2, 9, 4, negative 1, negative 7, 9, and 7, 0. Finding the inverse, so we take the point negative 2, 9 and make it 9, negative 2. We take the point 4, negative 1 and we make it into negative 1, 4. Negative 7, 9 becomes 9, negative 7, and 7, 0 becomes 0, 7. Go ahead and pause the video, do this one on your own, then hit play, see how you did. For the point negative 8, 6, you should have turned that into 6, negative 8. For 6, negative 2, you should have turned that into negative 2, 6. And for 7, negative 3, you should have turned that into negative 3, 7. The next thing we're going to do is we're going to find the inverse of function. So if we're given the function f of x is equal to 2x minus 5, to find the inverse, the first thing we do is we replace f of x with y. So now we've got y is equal to 2x minus 5. The next thing we do is we switch x and y. So all y's become x's, all x's become y's, and that'll change it to x is equal to 2y minus 5. And then we solve for y again. So now we add 5 to both sides. So x plus 5 is equal to 2y. Divide everything by 2. So I get x plus 5 over 2 is equal to y. And then generally we write it so that y is on the left. So we have y is equal to x plus 5 over 2. And then we switch it back into function notation, but we use the inverse. So we would say f negative 1 of x is equal to x plus 5 over 2. That is our inverse function. For our next example, we've got f of x is equal to x minus 3 over 5. Again, the first thing we do is we switch f of x with y. We switch x and y. So now we've got x is equal to y minus 3 over 5. So now we solve for y. The first thing we have to do is get rid of the 5 on the bottom. So we multiply both sides by 5 to get rid of it. So we get 5x is equal to y minus 3. And then we add 3 to both sides. And we get 5x plus 3 is equal to y. And again, we rewrite it so that y is on the left. So we would say y is equal to 5x plus 3. And then again, the last thing we need to do is put it back into function notation by replacing y with f to the negative 1 of x. And that would be equal to 5x plus 3. Our next example, we've got f of x is equal to 3x squared. So if we ever have a squared term, this is what we're going to do. We're going to do the same thing to start out with. Replace f of x with y. Switch x and y. Solving for y again, I'm going to divide both sides by 3 first. Now to get rid of the squared, I'm going to do the square root of both sides. And on the right, all that's going to do is cancel out with the squared, leaving just y. And then I leave the square root of x over 3 there. Rewrite it so that y is on the left, so y is equal to the square root of x over 3. And then again, write it back in function notation. So I would have f to the negative 1 of x is equal to the square root of x over 3. Go ahead and pause the video, do this last one on your own, and then hit play and see how you did. So once again, switch out y for f of x, and then we switch x and y. Solving for y, we add 6 to both sides, divide both sides by 4, rewrite it so y is on the left, and then again write it back in function notation, giving us an answer of f to the negative 1 of x is equal to x plus 6 over 4. The last thing we're going to talk about is we're going to verify that two functions are inverses of each other. So in order to do that, we need to do compositions f of g of x and g of f of x. And for both of those, the answer that we should get should be just x. Nothing more, nothing less, just x by itself. And that should be true for both. So if one or both compositions don't get that answer, then they're not inverses of each other. So if you do the first one and you get something other than x, you don't have to bother doing the second one because they're not inverses. So our two functions are f of x is equal to 3x plus 9 and g of x is equal to 1/3 x minus 3. So if we're going to do f of g of x first, remember g of x gets plugged in for x in f of x. So instead of 3x plus 9, I'm going to do 3 times 1/3 x minus 3 plus 9. Distribute the 3. 3 times 1/3 x is x, or 1x, but we don't need to write the 1. 3 times negative 3 is negative 9. And I add the plus 9 from the end. Negative 9 plus 9, I can add those together. They cancel each other out, leaving just x, which is what I want to happen. So I have to check the other one as well. G of f of x means I take f of x and I plug it into x in g of x. So instead of 1/3 x minus 3, I'm going to have 1/3 times 3x plus 9 minus 3. Distribute the 1/3. 1/3 of 3x is 1x, but we can write it as just x. 1/3 of 9 is positive 3, and I bring down the minus 3. 3 minus 3, they cancel each other out, leaving just x. So for both compositions, I got just x. These are inverses of each other. So I would say yes, they are. So for our next example, we've got f of x is 3x minus 3, and g of x is 1/3 x plus 4. So the first thing we're going to do is we're going to do f of g of x. So we're going to take g of x here, plug it in for x in f of x. So instead of 3x minus 3, I'm going to do 3 times 1/3 x plus 4 minus 3. Distribute the 3. 3 times 1/3 x is 1x, or just x. 3 times 4 is 12. Combine my like terms here. I get 12 minus 3 gives me 9. So I have x, but I also have this plus 9 right here. That means that this does not work. I don't even have to bother going to g of f of x because the first one didn't work. So these are not inverses of each other. So for our next one, we've got f of x is 2x squared minus 1, and g of x is the square root of x plus 1 over 2. Again, to start out with, we're going to do f of g of x, so we're going to take g of x and plug it in for x. So instead of 2x squared minus 1, I'm going to have 2 times the square root of x plus 1 over 2 squared minus 1. The only thing that happens when we square a square root is it cancels out, so I'm really going to be doing 2 times x plus 1 over 2 minus 1. Distribute the 2, it's going to cancel out with the 2 on bottom, giving me x plus 1 minus 1. The 1's will cancel, leaving just x. So for g of f of x, I'm going to do the same thing. I'm going to take f of x and plug it in for x here. So instead of the square root of x plus 1 over 2, I'm going to have the square root of 2x squared minus 1 plus 1 over 2. The minus 1 and plus 1 are going to cancel each other out. So I've got 2x squared over 2. The 2's will cancel out. So I'm really just taking the square root of x squared, which is just x. So for both of them, I get an answer of just x. So these are, in fact, inverses of each other. Go ahead and pause the video, do this last one on your own, and then hit play and see how you did. So if we do f of g of x, I should have 2 times 2x minus 3 plus 3. Distribute the 2, I should get 4x minus 6 plus 3. Combining my like terms, I should get 4x minus 3. That is not equal to just x, so therefore I can already say without doing g of f of x that these are not inverses of each other.